Okay, so now we're going on to the maximum range of a horizontal plane. Just remember, this is very different from just your range on a horizontal plane. What a maximum range means is, for example, like me, there's only a certain force that I can use to throw a ball. There's no way I can throw it any harder. But what I can do is vary the angle that I throw it at. So I could do a little throw like that, or I could try lob it up and throw it like that. And both of these would give you different horizontal distances that it would go. And what we're trying to find out is what that angle should be to give me the maximum distance that I can throw. So in that way, the velocity, so the force that I'm using, that's staying constant, but what's changing is the angle. For example, if I'm just doing a little throw, it'll just go there. But if I move the angle up a bit, it'll go a little bit further. If I move that up a little bit more, it would go further, and that would go further like there. But it gets to a point that if you do throw it up any higher, you gain a lot of vertical distance, but your horizontal distance actually diminishes. And if you go even higher, the horizontal range gets narrow as well, until all you're really getting is that vertical height rather than the horizontal distance. So you can see here, there's all these varying angles with which you can throw a ball. Okay, just remember the velocity here is constant. All right, so I'm not changing that. The only thing I'm changing is the angle. You can see that there's actually only one angle that gives you that maximum distance. So that's what we're talking about. What is this angle here that gives us that maximum distance? Now, a lot of students get confused between the range of your horizontal plane and the maximum range of your horizontal plane. Well, it's quite simple. With the maximum range, all you're given is the velocity, which is constant, and we don't know the angle, so we want to work that angle out to see when it gives us the biggest or the widest range. Whereas when we're just working out the range of something, it gives you both the velocity and the angle, so you're just working out the range for that specific one. So I think it's quite simple. It's all dependent on the angle. Here, so we just made it smaller so you can see, and what we're working out is that angle for the maximum range. And by working out the maximum range, we're going to be working with range as well. So this is a range of any one of those. The maximum of that is going to occur when sine 2 theta is a maximum. And that's because both v, your velocity, and g, your gravity, are constant values. We can't change that. The only thing we can change is the sine 2 theta. Sine 2 theta has a maximum value at 1. And that's because if you remember when we used to draw sine, it would oscillate between 1 and -1 like that. Remember how you would do this? So that's why we say sine of anything must be between 1 and -1. So therefore the maximum value of sine 2 theta is 1. The maximum value is 1, substituting that in, therefore the maximum range is actually v squared on g, which you can see here. V squared on g is not going to be an answer when we're writing it out, so we're going to work that out next in the question. But what I want you to notice is that to work out the maximum range, what we're doing is we're using the range equation, and then we consider what the maximum of the only variable is. All right, that's the basics of it. So let's have a look at question 13 here. So in this question, we want to find the angle which makes the maximum range. So in essence, we want to find that angle there. So firstly, starting out with a range equation, remember how we just worked that out in the previous module? Yeah, but don't worry, in the exam, it would be in the previous question. So v squared sine 2 theta on g. And we said that the maximum range occurs when sine 2 theta is a maximum. And sine 2 theta reaches a maximum value at 1. So that means sine 2 theta equals to 1. That's a maximum. Remember, we're wanting to work out the angle, which means we want to work out what that theta is. Sine 2 theta equals to 1. So 2 theta, using inverse sine of 1, okay, that gives you 90 degrees. So 2 theta equals to 90 degrees. So therefore, in this case, theta equals to 45 degrees. So your maximum range of which you can throw something occurs if you throw it at 45 degrees. All right? Now, when a question asks you what the maximum range is going to be, I don't want you to ever say just 45 degrees. You need to go through this whole process, including writing out maximum range occurs here, maximum value of is 1, substituting in and working that out to get your final answer.